Alright, so here is our review video for the first quiz on 13.1 through 13.2. Again, I highly suggest that you try these problems on your own first and come back and check them, or come back and watch the ones that you were for sure stuck on. So make sure you look through it now, figure out which ones you think you can do on your own, and then come back to it and watch the ones that you need help on, or maybe check your answers with it. Well, definitely check your answers with it. I don't know why you wouldn't check your answers with it. Alright, number 1, list the terms for the following sequence. So I have a sequence. This tells me that I am finding terms 1 to 6. So I need to start with A1. I need A2, A3. Alright, let's just start putting them in. 3 times 1 minus 4. Well, 3 times 1 is 3, minus 4, 1. 3 times 2 minus 4. That's 6 minus 4 is 2. 3 times 3 minus 4. That's going to be 3 times 3 is 9. So 9 minus 4 is 5. A4. 3 times 4 minus 4. So 12 minus 4 is 8. A5 is 3 times 4 minus 4. That's, oops, I need 5 here. That's 15 minus 4 is 11. And finally, A6 is 3 times 6 minus 4. That's 18 minus 4 is 14. Now, remember, list is your key word here, so let's list them. -1, 2, 5, 8, 11, 14. So that is your list, your final answer. Alright, problem 2, same thing, except for it's an infinite sequence, which all that means is you need a little bit of a dot, dot, dot at the end. So first 4, oops, that should say 4. So 4 terms. I need A1, which is 1 over 1 times 1 plus 1. Well, that's 1 over 1 times 2, which is 1/2. What about A2? That's 1 over 2 times 2 plus 1, which is 1 over 2 times 3, which is 1/6. Alright, now I need A3. 1 over 3 times 3 plus 1, which is 1 over 3 times 4, which is 1/12. And finally, A4 is 1 over 4 times 4 plus 1, which is 1 over 4 times 5, or 1 over 20. Again, list, so list them, 1/2, 1/6, 1/12, 1/20, dot, dot, dot. And I ran out of a little bit of room there, so just make sure that you have enough room to put your dot, dot, dot. Alright, finding the formula. So remember, this is where we need to think back. Typically I try to see, okay, can I multiply 3 by anything to get 5? No. Can I add anything? Well, if I add 2, let's try that again though. 5 plus 2 is 7. 7 plus 2, so I'm looking like I'm adding 2. So add 2 means that maybe I should use that sequence 2n. Well, let's try that. So A1 equals 2 times 1, which is 2, but that doesn't equal 3. How can I get from 2 to 3? Add 1. So now let's modify this formula here and do an to n plus 1 and see if that works. So again, now I need to check. So A1 equals 2 times 1 plus 1, which is 3. Check. A2 equals 2 times 2, which is 4, plus 1. That's 5. Now I'll just stop there. Do at least one more. 2 times 3, which is 6, plus 1 is 7. Okay, so I'm pretty comfortable that that is my series, or that is my sequence formula. Alright, what about the next one? Now, I noticed right away that I have a positive, negative, positive, negative. So plus, minus. That tells me alternating. So I probably need to use that -1 to the n, or -1 to the n plus 1, or n minus 1. We just have to figure out where we start. If we start at 1, we use minus 1. If we start at 2, we gotta use plus 1. Or 4, or any other different kind of thing. So, let's think about this. If we want positive or negatives, actually. Ignoring the alternating, I have 4, 8, 12, 16, ... Well, if I multiply by 2, I get 8. But multiplying by 2 doesn't get me 12. So what's another way I can get there? Well, think about adding. Plus 4. To get here, I'm going to add 4 again. Add 4. So it looks like, again, I'm using that an equals 4n. In this case, 4n, 1 works, 2 works, 3 works, 4 works. But I need the alternating pattern. So I need that negative 1 to some power. Now, since I start positive, I want this. I need negative to plus 1 or minus 1. In this case, it actually doesn't matter which one you use. Because if I put 1 in, I get squared, that works. If I put 1 in, I get 0, that works. Since I'm just attaching it on, usually I choose n minus 1. Right? So I'm just attaching that on to my series, or my sequence. You'll mostly see more ones like this on your quiz. This one, where you have to combine 2, is a little bit more expansion. Find the sum of the following series. So sum means find all the terms first. Remember, this is where we start, and this is where we end. So I'm going to start with A1, I'm going to do A2, I'm going to find A3. I'm going to add them all together, because I want the sum. So negative 1 cubed, negative 2 cubed, negative 3 cubed. Alright, well again, you can just use your calculator, or no, it's going to be negative through 1 to the power negative 1. 2 times 2 is 4, times 2 is 8, so that's negative 2 times negative 2 times negative 2, which is negative 8. This is negative 3 times negative 3 times negative 3, which is negative 27. Now add them all together. Negative 1 plus negative 8 plus negative 27, all for a grand total of negative 36. We're going to do the same process over here. We're going to start at 1, A1, end at 4, A2, A3, A4. And we're going to add them all together. So 2 to the 1 minus 1, 2 to the 2 minus 1, 2 to the 3 minus 1, 2 to the 4 minus 1, 2 to the 0, which is 1, 2 to the first power is 2, 2 squared is 4, and 2 to the third is 8. So 1 plus 2 plus 4 plus 8 equals 15. Adding them all together. Alright, so now we get to some of the tougher questions. The index change, and then those word problems. So remember, when we want to rewrite an index from I, well, what do I start with? I'm going from J. I want to take J, and it needs to be replaced with I. So I want J to equal something. Well, how do I get to J? I'm going to use I to get to J. So I, if I start at 5, and I want to go to 1, what do I need to do? Well, I need to subtract 4. So subtract 4 from it. Well, now I can use that to figure out what my new end point is. If that is 20, and that's J, then I have 20 equals I minus 4. Well, plus 4, then I equals 24. So that's my new ending point. I'm going to go ahead and rewrite this over here. So 24i starts at 1. But I still need to replace out my formula. So my formula, I'm going to write it here, is 2j minus 3. But I want it in terms of I. So let's substitute in our I minus 4 for j. So we've got 2 times I minus 4 minus 3. Distribute your 2, you get 2I minus 8 minus 3. Combining like terms, we get 2I minus 11. And then that goes into my formula, 2I minus 11. And now I've successfully changed the index on that problem. Alright, the last two problems here ask us to kind of use our knowledge of sequences to figure out the ending. So remember, when we look at a word problem, we want to see what our starting point is. So she invests $10,000 in the bank in 2009. So 2009, we have that. If we increase by 3% a year, that's going to be adding 0.03 of initial. How much will we have in 2010 and then 2015? So two separate answers here. So remember, 2009 was 10,000. So in 2010, we have a new total. We're going to take that 10,000 and we're going to add on 3% of it. So you want to go ahead, calculate that in your calculator, and figure out how much you get. You get $10,300 in 2010. So that answers one of our questions here. Now, again, take that and find out 2011 and keep going with it. So 10,300, and I'm going to add on 0.03% of it, which now is going to give me 10,609. While in 2012, I'm going to take that 10,609 and keep adding on my 3%. So now I'm at 10,927 and 27 cents. So keep going. We get 2013. We've got 10,927 and 27 cents. Add on 0.03 of it. Which ends up equaling 11,255.09. Alright, now we're in 2014. 11,225.09 plus 0.03 of 11,225.09. We're at 11,592.74. And finally, we've made it to 2015. That's our final year we need, so 11,592.74 plus 0.03 times 11,592.74, and we get $11,000, 940.52 in 2015. So again, yes, that's a lot of work. There is an alternate way to do this. You can do your initial amount. Since we're increasing, we're going to do 1 plus the rate to the year. So in the first year, you're going to use that to get this. That would be n equals 1. And then that would be n equals 2, n equals 3, 4, 5. This would go ahead and be n equals 6. So you can do that. But again, that's something that we haven't really talked about totally. We've just kind of gone ahead and done each year individually. Alright, and we have one more problem here. Jonathan buys a car for $45,500 in 1999. So that seems like my initial. It's depreciating by a constant rate, so minus this each year. So it wants to sell the car next year. How much will it sell for? So next year, how much will it sell for? And how about in 2005? So again, we need to figure out those two things. So if it's in 2000 would be the next year, we're going to take 44,500 and we're just going to subtract that constant rate. So subtract out, then we're going to go ahead and we're going to get 43300. That should be 43,000. My bad. So $43,000 and 300. Now, since this is a constant rate, we know we're just subtracting out that each year. You can take that initial and subtract out one per year, where n equals years later. So we can go ahead and quickly just go ahead and do how many years later will we have? Well, 2000, 2001, 2002, 2003, 2004, 2005. That's 1 year, 2 years, 3 years, 4 years, 5 years, 6 years. So times 6, and we end up with 37,300. In 2015. Again, I'm going to go ahead and show how we get there. We can then take our last amount, 43, minus 1,200. That will land us at 42,100. Again, 42,100. We're going to subtract out 1,200 to then get us to 40900. Take that 40900, subtract out the 1,200 again, and get 39,700. 39,700. Subtract out 1,200. We're at 38,500. Take your 38,500 and subtract out 1,200. And finally, we're at 37,300. So that's where we can go ahead and get the answer by just going ahead and getting each individual term. Alright, so make sure you look back at your notes. Hopefully this was helpful. Tomorrow's quiz, again, you need to know how to write those. You need to know how to change index. You do need to know how to do word problems similar to this. You need to know definitely how to find sums. And again, just know the difference between finite and infinite series.